Welcome, compadres. Today I'm going to show you how to pull out connector forces in Abaqus. So before you do any joint analysis or fastener analysis, you need to be able to pull out the forces, the translational and moment forces, whatever you're looking at, so that you can post-process it later on. So we're in the step module here, and if you recall, I added connectors here on the bottom. There's 4 connectors to simulate fasteners. So the first thing I'm going to do is I'm going to go up here and I'm going to create a set of connectors. So let's go ahead and create a set. Let's call it fastener set. Press continue, and what we want to do is we want to select these connector elements. They're 1D elements, but you can go up here and you can actually toggle this on where you can just select the assembly wires. So that's what we're going to do. I'm going to select all of those. I have 4 of them, and then I'm going to middle mouse click. Okay, so I've created my connector set. We can verify that by going to Set Manager and then doing Edit, and it'll highlight the locations that you selected, the connectors that you selected. So we're good there. So we can go ahead, and what we want to do next is we want to create we can either do a field output or history output. I'm going to do history output for now, but you can do it either way. So we're going to call it the fastener forces. And then you get a dialog box where you can go ahead through step through this, and we want the whole model. No, we want a set. We want to select the fastener set we just created. Okay, and that's alright for right now. And so we can go down in here, we go to connector, and I'm going to go into total forces and moments, and I'm selecting CTF1, CTF2, and CTF3 because that's I define the stiffnesses in the X, Y, Z directions. I didn't define them in the moment stiffnesses, right? So I'm not going to be able to pull out any moments on this on these fasteners. You'll understand why when we do the post-processing. So I created my history output called fastener forces. Now we can go ahead and go run our job. So I'm going to run this G-load job. That's where we have our history set is pulling out of that step. So I'm going to submit this, and we'll wait a second, let it complete. Okay, it's completed. So next step we want to do is we actually want to go pull those loads out so we can put them in an Excel spreadsheet. You can write scripts for this, but you know, for I guess just because not everybody's familiar with scripting, we're just going to go ahead and do it the old-fashioned way. So I select results, it'll pull up my ODB, and then what I'll do next is I'll go down here to create XY data. I want to select history output, and then here's my connector forces. I should have a total of 12. Looks like I do. So I'm just going to select all of those connector forces, just do save as is. That's fine with me right now. Next I want to go to report. I want to do XY. Okay, and this is where I'm going to select just my X forces, my CTF1s, my X reaction forces, and I'm just going to go ahead and append it to this report file. So everything, I'm going to use the default settings, I'm going to append that. Okay, and then I'm going to append my Y direction reaction forces for my connectors. Okay, I'm going to select apply, and then I'm going to do my Z or my axial, select apply. And I do them individually because the way Abaqus reports, it appends this to a notepad or a note text file. It's very it's easier to do it if you select just the specific ones. It'll organize it a little bit better. It's not real easy, but this is the easiest way I've found without writing a script. So after we've done that, it's going to append it to this abaqus.rpt file. And so if we go to File, set work directory, it'll tell us what directory it put it in. So it put it in the temp directory right there. We can change that if we want to, but that's the default value. So I'm going to go into my temp up here, and here is that Abaqus report. I'm going to right click and do edit with notepad, and you can see here it appended our connector forces in the X direction, our connector forces in the Y direction, and our connector forces in the Z direction. So what I have to do now is do it old-fashioned. I have to copy these values, and then I have an Excel spreadsheet. I'm going to paste these, and I'm going to do the same for the other forces here. I'm going to keep them organized, and then do the last one here. I'm going to delete this equal sign because I don't know why I pulled that in, but I'm going to delete that. And then I'm going to go to the data tab, text to columns, and then look at how it's going to split these. You can see it doesn't split them very well, so actually I'm just going to do it individually. Text to columns, there we go. I'm going to do that for each one. Okay, so pull our connector forces. Now I'm going to organize them. I'm going to transpose these. So transpose our X force reaction forces, our Y reaction forces, and you can see this is pretty. It's pretty labor intensive, I guess. That's why we'll talk about writing scripts later on. Okay, now what I want to do is I want to associate the correct element. So it says this is element 3, 4, 5, and 6. So I'm just going to create some headings here. 3, 4, 5, 6. And then CTF1, CTF2, CTF3. Okay. So we have pulled out all our connector forces. Now we can actually go do some post-processing in Excel, as I'll demonstrate in the upcoming videos. So this is kind of the building block. You need to know how to do this to start your post-processing. So I hope this was informative, and I'll see you next time. Adios.